In modern robotics and autonomous systems, large amounts of data are continuously generated by sensors, control systems, and robotic software platforms. This data includes robot telemetry, sensor streams, motion information, LiDAR point clouds, and communication signals between robotic components. To efficiently store, exchange, and process this information, robotic systems rely on specialized data formats designed for robotics frameworks, simulation platforms, and embedded control systems. These formats are widely used by robotics engineers, autonomous systems developers, data engineers, machine learning engineers, and artificial intelligence systems working on robotic perception, navigation, and control. Let us explore some of the most commonly used robotics data formats. The first format is Robot Operating System Bag, commonly known as a robot bag file. This format was introduced by Willow Garage in 2007 as part of the robot operating system ecosystem. Robot bag files are binary log files used to record robot sensor data, telemetry streams, and system messages during robot operation. They allow engineers to record and replay robot data for debugging, testing, and machine learning experiments. The next format is Unified Robot Description Format. This format was introduced in early robot operating system frameworks around 2008. Unified Robot Description Format uses extensible markup language to describe the physical structure of a robot. It defines robot components such as links, joints, sensors, and kinematic relationships between parts. This allows robotics frameworks to understand the physical structure of a robot for simulation, visualization, and motion planning. Another important format is Simulation Description Format. This format was introduced by Open Robotics in 2012 and is widely used in robotics simulation environments such as Gazebo. Simulation description format uses extensible markup language to describe robots, environments, physics properties, and sensors used in simulation systems. It allows robotics engineers to test robot behavior in virtual environments before deploying robots in the real world. Next is the point cloud data format, commonly called point cloud data. This format was introduced by the point cloud library in 2011. It is used to store three-dimensional point cloud data generated by LiDAR sensors, depth cameras, and other three-dimensional perception systems. Point cloud data is widely used in robot perception, mapping, obstacle detection, and autonomous navigation. Another important format is the LiDAR Data Exchange format, commonly known as LAS. This format was introduced by the American Society for Photogrammetry and Remote Sensing in 2003. It is a standard format used to store large-scale LiDAR point cloud datasets collected from aerial scanners, drones, and autonomous vehicles. Finally, we have Controller Area Network Bus Logs, commonly referred to as CAN bus logs. The Controller Area Network Protocol was introduced by Bosch in 1986. It is widely used in robotics and embedded systems for communication between sensors, controllers, and actuators. CAN bus logs store communication data exchanged between different robotic components within a robot or autonomous system. Together, these data formats enable robotics platforms to record, simulate, analyze, and process the large volumes of data generated by modern robotic systems. Understanding these formats is important for robotics engineers, data engineers, and machine learning engineers working on intelligent robotic platforms and autonomous systems.